Hey, this is Mr. Weisfeld. Thanks for joining me. We're talking about PS2B, that's properties of the periodic table, trends, and so on. So, hey, grab your periodic table and let's get going. Here's mine. We're talking about this worksheet right here. This was PS2B. There was a practice one. It was green, and then the real one is an assessment for PS2B. So, if you can get through this video, you should be able to pass the assessment. Be sure to take notes. If you have any questions, come talk to me about it. But let's get started. So atomic number 28 right here, that's atomic symbol. Here we go. 28 is nickel. N-I-C-K-E-L. Is it brittle? All right. Here's the questions we want to ask ourselves. Is it a metal? For all of these, this is what's going to help. Is it a metalloid? So is it a metal, non-metal? You know, it kind of sits in between M and M. And is it non-metal? NM, let's call it, or non-metal. Write it out. So if I look at the periodic table, remember that everything, let's see here, everything on this side of the periodic table, see this line? Everything here over, so this way and down, those are all metals. These ones in green, those are called metalloids. So they're not metals and they're not nonmetals. And then remember, everything on this side and up from that line are nonmetals. So let's just make this point on there. You gotta know that for PS2B. You just gotta keep that in your head. So below this line, metals. Above this line, nonmetals. So nickel is a metal. Let's just put a metal here, M for metal. And what we know about metals is that they are ductile, they are malleable, they are shiny. All those are properties of metals. And the opposites of those, so being not ductile, being not malleable, so brittle, those are the properties of nonmetals. So this is a property of a nonmetal. So nickel, metal, is brittle? False. And you know what I might do is I might circle it just to be quicker, so that's false. All right, number 5, periodic table. Number 5, over here, boron. Boron B. Boron is a metalloid. So it is not a metal, and it is not a nonmetal. So you have to say that it is false for being a metal. All right, move on. Aluminum, Al. Al is number 13. Aluminum. Write that in here. How many valence electrons? Okay. Over here, the noble gases have 8 valence electrons. They're all full up. The number of valence electrons goes down as you go to the left here. So this is group 17, which has 7 valence electrons. This is group 16, which has 6 valence electrons. 15, 5 valence electrons. 14, group 14 has 4 valence electrons. Group 13, 3 valence electrons. Aluminum is in group 13, has 3 valence electrons. You know, those valence electrons are used for reactions. We're going to talk about that in PS2C a little bit more. So just hang tight. Look at the group, the column that things are in. Remember that beryllium, or these guys, this is the alkaline earth metals, orange. These guys are in group 2. They have 2 valence electrons. 2 valence electrons. And then those guys in group 1, they have 1 valence electron. The guys in group 1, alkali metals. Okay? So that should be enough for you to answer the valence electrons for anything. Oh, these guys here in the middle. Transition metals, they could have 2 or 3 or 4 valence electrons. Those are all pretty good answers. I'm not going to ask you so much about those. The more important thing is to know these elements in groups 13, 14, 15, 16, 17, and 18, and groups 1 and 2. All right. Scandium, SC. Where is it on the table? Over here. It's got atomic number 21. Remember that atomic number is the same as the number of protons. So atomic number equals number of protons. So 21 is the right answer here. Pretty easy, but let's not miss these, okay? SN, next one, tin, number 50. Tin. Real quick, that's a 5. 50. Okay, is it shiny? Well, question to ask yourself, is tin a metal? Is it a non-metal? Or is it a metalloid? In other words, metalloids sit between metals and the non-metals. Tin is shiny because it's a metal. Tin is a metal. Check it out. It's here. It's below this line. So that means it's a metal. So, true. Let's circle true. All right. Molybdenum. Molybdenum is number 42. Over here, 42 on the periodic table. Molybdenum. Is molybdenum a metal or non-metal, or is it a metalloid? You tell me. It's a metal. That's right, because it's over here. It's below this line, below and to the left of that line. It's in the transition metals. Chemical properties for metals. These are some things we have to remember. So let's do a little table down here. I've been doing this table with a lot of people on their papers, so let's just kind of reproduce it here. Metals, metalloids, non-metals. What we did is we said metals are shiny, metals are malleable, metals are ductile, and those are all physical properties. Physical properties. Non-metals, they're dull. They're brittle. That means they don't break very cleanly. Well, they break and they shatter. And also, they are not malleable, right? They'll bend, they'll break. Metals will bend and you can bend them back, right? Many times at least. These are all physical properties. So the only real chemical property that we've had is metals react with acid. So let's write this down. React with acid. And nonmetals do not react with acid. Okay? And then the metalloids, they go both ways. There's some, that is to say, there's some metalloids that are shiny, some that are dull, some are brittle, but some are also ductile. You know, you can pull them into wires and things. So, safest thing to say about metalloids is if you're not sure, they can go both ways. But when it comes to chemical, the nonmetals do not react with acid, and the metals react with acid. That's a chemical property. And as I write this, I'm thinking that they also rust. So you can also say that metals rust. When was the last time that you saw plastic rusting, right? No, that has never happened. So, rusting. Okay, so back up. Molybdenum, chemical property, reacts with acid. React with acid. All right. Moving on. Number 7. All right. Number 13 is aluminum again. So Al, I apologize for these ones that were on here twice. Aluminum. You tell me now, is aluminum a metal or a non-metal while I'm writing this? Metal? Non-metal? It's a metal. It's below this line, right? So aluminum is not dull. False. It's shiny. Let's do number 8, sodium. Sodium's over here, Na. Metal? Non-metal? Metalloid. Well, it's to the left of this line here and down or so. So sodium's a metal. So it's not a metalloid. It's not on that line. It's not one of these green ones, right? So false, metalloid. Sodium is number 11. It's Na. All right. 3. Atomic number 3. That's called lithium over here. Li. Lithium. Is lithium a metal or non-metal? It's a metal. It's over here to the left. All right. How many neutrons does lithium have? All right. So lithium, let's zoom in a little bit here. Lithium has an atomic mass of 6.941. That is almost 7. Okay? So the atomic mass is equal to the number of protons. The number of protons is 3 plus the number of neutrons. So 3 plus something equals 7. What's the something? 4. Lithium has 4 neutrons. So remember, neutrons equals atomic mass minus protons. Or if you do the algebra right, we know that atomic mass is protons plus neutrons. Why? Because the protons and neutrons are the stuff in the nucleus. That's what gives the atom most of its weight. SB. Let's zoom out here again. Let's see here. SB is over here, antimony. It is atomic number 51. And if I'm going too fast, hey, just pause it. Find out where that is. Make sure you can find it. Antimony is in which period? Remember, the periods are the rows. They go 1, 2, 3, 4, 5, 6, 7 are the periods. And it looks like antimony is in period 5. So we'll write down period 5, and we're good. Ag. Next one. Ag, silver. It's number 47. Silver. Give a physical property. Hey, okay. Silver, is it a metal or non-metal? It's a metal. That means we can pick one of these. Silver should be shiny and malleable and ductile. Well, cool. It's malleable. People make it into jewelry, all sorts of stuff. So let's say it's shiny. That's a physical property. You could also say it's a solid. Or if it was a liquid, you could say it was a liquid or a gas, but it's not a liquid. But anyway, you've got a lot of choices for physical properties. Hey, don't be so stumped by physical properties. Almost anything can be used as a physical property, or you can mention anything. Te. Next one. Tellurium. It's here. Number 52. Tellurium. Tellurium. And it's number, what did I say? 52. Is tellurium a metal? Ooh, you know, it's a metalloid. That means it could be conductive. Conductive is a property of metals. Let's go back down here, add it to our list. Conductive. Conduct. It's also a physical property. Conductive is. So, but you know, when you're a metalloid, you could go either way. So you know what? We have to say that we don't know, or false. Because it's a metalloid. So let me just put a reason here. Metalloid. Alright. Next one. Iodine. Iodine's over here, number 53. It's in the halogens. Remember, these are the halogens. This column here. And then we've also got the noble gases in the far right. Okay, we're on number 13. Iodine. Symbol for iodine is I. Let's look at the periodic table. I is over here, as we said, in the halogens, number 53. Is iodine a nonmetal? Well, that's a good question. We've been working on this question for all the elements. Since iodine is to the right of this line and above this line, it is a nonmetal. That's true. Moving on. Palladium. Palladium is PD, here number 46. PD, 46. Is palladium a metal? Keep coming back to this question. It is a metal since it's here to the lower left or to the left of the metalloids. That means it's a metal. All metals are ductile. That's true. CO, moving on. Cobalt, CO. Cobalt's number 27 here on the periodic table. C-O-B-A-L-T. Cobalt 27. Atomic number 27 also means it has 27 protons. If cobalt has 27 protons, and if it has no charge, that is, it's a neutral atom, then number of protons equals the number of electrons. So 27, because in a neutral atom, the number of protons equals the number of electrons. That's not necessarily true for ions. We talk about that in PS2A, so stay tuned. Mn. Mn is manganese, not magnesium, manganese. Here it's number 25. The question is manganese. What is the atomic mass? So atomic mass is not the same as the atomic number. Don't confuse those two. Atomic mass, let's zoom in a little bit here for manganese. Right here, this is the atomic mass. This is the atomic number. Not the same. So atomic mass, 54.94. You can write it out, 54.94. You don't need to round it up or anything. We're just writing the number down from the periodic table. Alright. Number 17, vanadium. Vanadium right next door. Number 23, vanadium. Is it malleable? Why, yes, it is. Atomic number 23. It is malleable because it's a metal, right? It's here in the metals, and so true. Hydrogen, here we go. Hydrogen, up here. Atomic number 1. Group 1. H1 is in which group? Remember, groups are the columns. So columns. Hydrogen, group number 1. Okay, zoom out again. Next question. Gallium, G-A-L-L-I-U-M. It's right here, number 31. Ga. Is gallium a noble gas? So noble gases are over here on the far right. Helium, neon, argon, krypton, radon, xenon. Those are the noble gases, so gallium's not a noble gas. False. Okay. Sn, we had this once before. Sn is tin. Sn right here. Atomic number 50. What is more reactive than tin in the same period? So in this row, we want to know which of these is more reactive. So we talked about when it comes to the metals, to get more reactive, you go to the right and down. So to the right and down are more reactive than tin, but we're staying in the same period, so in the same row. So you could pick anything: indium, cadmium, silver, palladium, rhodium, ruthenium, strontium, rubidium. Let's pick the one that's most reactive, rubidium, in that same period. Nothing beats rubidium when it comes to more reactive than tin. Alright? And then GE, last one, germanium. Germanium is atomic number 32. We'll write that right here, germanium. And we're wondering what's more reactive in that group. So when it comes to metals, more reactive is going to be to the left and down. Germanium, though, ooh, it's a metalloid. So what is more reactive than a metalloid? Well, for instance, it could be a metal in this case because it's close to these metals, or it could be a non-metal. So let's review the rules for reactivity. If let's say germanium is acting more like a non-metal when it comes to reactive, the group is the column. So the thing in that same group that is to the right, so when you're in the nonmetals, more reactive is to the right and up. So since we have to stay in this column, up from germanium is carbon. Carbon is more reactive in that group. Alright, so that's been a quick review of what you need to know or what you need to remember to pass the assessment for PS2B. I hope this was helpful. This is a sample assessment. There are other assessments out there with different elements in there. So give it a shot. Come by before school, after school, Saturday school, and take this reassessment. Thanks for listening.